Happy Thursday, everybody. Today is Unit 13, Day 4, Thursday, 4:30. Please have out Unit 13 note packet to page 7 and your reference tables. Actually, it should be page 8. Not page 7, page 8. There's no new skill check tonight, so just please make sure that you have completed the indicator skill check by 11:59 this evening. There have been 2 skill checks so far this unit. The introduction to acids and bases and electrolytes was the first one, and then the indicators one that you should have worked on last night. I'm sure this is how Dave feels about me after all this time. So please have out your packet to page 8. What we're going to do today is we're going to talk about how there are actually 2 different ways to define acids and bases. They're called acid-base theories. Today we're going to do the first theory. Tomorrow you're going to learn the second theory. But it helps to explain the behavior of acids and bases. And the first theory we're going to be doing is called the Arrhenius theory. So it's just a way to define an acid and to define a base. So we're going to start with acids. And what I did was I took out a little picture snapshot of table E, which is your polyatomic ions table in your reference table. So have that out in front of you. I put it here so it makes it easier to reference. But Arrhenius said that an acid is a compound that ionizes, meaning forms positive ions and negative ions, in an aqueous means dissolved in water, solution, to yield H+. H+ is the hydrogen ion, or H3O+. And if you're like, what the heck is H3O+? Well, this is why I put table E out. H3O+ is right here. That represents hydronium ion. As the only positive ions in solution. So let's reread that over. An acid is a compound that ionizes in an aqueous solution to yield hydrogen or hydronium as the only positive ion. So I can draw a little picture of this once we get into the examples afterwards. So what that means is an acid, if you put it into water, it's going to produce H+ ions or H3O, which is hydronium, plus ions as the only positive ions in solution. That's what that means. When you put something that's an acid in water, it's going to break apart and produce either hydrogen or hydronium ions as the only positive ions in solution. And you can actually write it as an equation here as well. So here's an acid, hydrochloric acid. If you put it into water, it produces hydronium as the only positive ion. Notice it's a positive. And then it also produces chloride ions. But it's the fact that a hydronium ion is produced as the only positive ion that's what makes it an Arrhenius acid. Other examples of acids, H2SO4, HCl, CH3, COOH. These are all acids. If you're unsure about what substance is an acid, remember table K. These all produce either hydrogen or hydronium as the only positive ion in solution, even the organic acid. This is just a way to define an acid. That's it. But you got to be a little bit careful. Not all compounds that contain a hydrogen are acids. So, example, water, H2O. That follows that general formula of an acid that starts with an H, but it's not an acid or a base. It's neutral. So be careful. Water is not an acid. CH4, there's a hydrogen in there. But this is an organic compound. Remember, organic compounds contain carbon and hydrogen. This is methane. This is neither an acid or a base. C6H12O6. This is glucose. This is a sugar. Even though it has a hydrogen, that doesn't make it an acid. H2O2. This is hydrogen peroxide. That's what you put on your cuts. It's not an acid either. And NH3. NH3 has a hydrogen, but it is not an acid. It's actually a base. So you kind of have to be careful. Just because you see an H out front doesn't make something an acid. This is my hint to you. When in doubt, check table K. If you're given a problem and asks which of these is an Arrhenius acid, find the one that's on table K. They're always going to give you something that's on there. Just remember the definition of an Arrhenius acid is it's a compound that when you put it into water produces either hydrogen or hydronium, and if you don't remember what hydronium is, it's right here, as the only positive ion in solution. And always check table K to figure out what the acid is. Good. All right, now we're going to talk about an Arrhenius base. This is page 9. So unlike an acid, which produces H plus or H3O plus as the only positive ion in solution, an Arrhenius base is a compound that ionizes to yield OH minus. Now, if you don't remember what OH minus is, that's why I put table E up there. OH minus is a hydroxide ion. As the only negative ion in aqueous solution. So the definition of a base is when you put it into water, it produces a hydroxide ion. So you can kind of draw that right here. Let's say you put NaOH, which is a base, into water. It's going to create Na plus and a bunch of OH minus. So it's the presence of that OH, this should be a minus. It's the presence of that OH minus as the only negative ion in solution that makes it a base. And this is kind of the written out form. You've got a base, you put it into water, it produces, in this example, a sodium ion, and then it produces the hydroxide ion. And it's the fact that there's a hydroxide ion as the only negative ion in solution that makes it a base. Some example of bases. As I said, sodium hydroxide. You've got calcium hydroxide. Notice the name's hydroxide. If you're ever confused about what is a base, go to table L in your reference table, and all the common bases are listed there for you. You don't have to guess. You don't have to memorize. Kind of like with acids, you got to be aware. Not all compounds that contain an OH minus are necessarily bases. For example, HOH. Notice there's an OH. HOH is just a fancy way to write water. This is water. It's not an acid, and it's not a base. CH3OH. This ends with an OH. Can't even tell me what this is if it's got carbons and hydrogens out front and then an OH. This is an alcohol. This is the one they try to trick you with all the time. Beware of the alcohols. These don't conduct electricity. These are non-conductors. And then the last one that's a little tricky is CH3COOH. Notice this one ends in an OH as well, but it has this Cu on the end. Remember that Cu is an organic acid, so this is actually an acid. So just be aware, just because it ends in an OH doesn't necessarily mean it's a base. So if you're ever unsure, check table L for your common bases. If it's on here, it's a base. Okay, so what I'd like you to do at the bottom of page 9 is do these 2 practice problems. You can pause the video, make sure you have table L and K out in front of you, as well as table E if you need to reference what a hydroxide or a hydronium ion is. Okay, so question 1, which compound when dissolved in water is an Arrhenius acid? Basically, this is just asking which one of these is an acid. The Arrhenius part, don't get thrown off by that. They're just meaning which one of these is going to produce either this or this as the only positive ion in solution. So all you need to do is you need to check table, I think it's table, which do I have on there? Table L or K? I never remember. You need to check table K and figure out which of these substances is on table K. And if you look, the only one on table K is HCl. CH3OH, that's an alcohol. That's not an acid. NaCl is a salt because it's a metal and a nonmetal. And NaOH is a base. It's found on table K, or excuse me, L, right here. So it's a base. So if you're asked which of these is an Arrhenius acid or an Arrhenius base, just check tables K and L. Great. And then 2, which ion is the only negative ion present in an aqueous solution of an Arrhenius base? Now remember, an Arrhenius base, when you put it into water, produces OH as the only negative ion. OH, if you can't remember, is hydroxide. So you should have chosen hydroxide. Hydride is H minus. Hydronium is H3O plus. And hydrogen ion is H plus. These two are associated with an acid. So what you want to take away from this, always use table L and always use table K to identify your acids and bases. You want to remember hydrogen and hydronium ions, those are associated with acids. And you want to remember a hydroxide ion is associated with a base. That's really the main thing from today. It's just a way to define an acid or a base. It's kind of your first theory. Tomorrow we'll do the second theory. It defines an acid and a base in just a different way. All right, so have a great day. Tomorrow's Friday, whoop-de-doo. No new skill check, just make sure you finish the indicators one. Bye, guys.